Let's say I want to compute this limit, and I want to use the fact that this is a nice, friendly, continuous function to do it. So here's what I know. The function here, 1 over x minus 2 times x minus 1, that counts as a rational function, which means it's continuous on its domain. I also can tell right away that its domain is all real numbers except 1 and 2. And this implies that this function is continuous everywhere except 1 and 2. And so this means for sure that f is continuous at 0. It's not continuous other places, but it is continuous at 0, and this means that the limit is easy to compute. You simply substitute 0 into the function, and you get 1 over 2. To explain this graphically, here's a graph of f of x equals 1 over x minus 2 times x minus 1. And you can see that it has a couple of giant discontinuities in the graph. And that might make you worry that you're not allowed to just plug in the 0 to evaluate the limit. But you are. So here's where x equals 0, and the y value of the function there is 1 over 2. And there is a big old discontinuity here at x equals 1, but here's what I'm trying to say. That's really far away from x equals 0. In terms of limits, that's a huge distance. And always with limits, the secret is that you are able to zoom in as much as you like to evaluate the limit. So if I were to zoom in here, I would only see this much of the function. It's very clearly continuous in an interval around x equals 0, so I absolutely don't care about what's happening at 1 or 2. It only matters what's happening really, really close to 0. Here's a second example. I want to evaluate the limit as x approaches pi over 3 of tan x. Now, tan is a trigonometric function, and it is also continuous on its domain. It has a very messy domain, but it's continuous on its entire domain. Pi over 3 is definitely in its domain. Therefore, this limit is equal to tan of pi over 3, or radical 3. And once again, here's a graph. So you know that tan x has infinitely many vertical asymptotes, infinitely many matching little swoops. And so when I mark the point pi over 3, comma radical 3, you might worry because there's actually a vertical asymptote right here at pi over 2 and it seems very close, but it's not. If you were to zoom in on this little section of graph, you could see that tan is continuous around pi over 3, and that's all you really need.